Hello, my dear students. My name is Dr. Amit Tomar. I am from Central University of Jammu campus. I am Assistant Professor in Department of Physics and Astronomical Sciences. Today, I am here to present a video lecture on your CUET entrance examination in physics subjects. The topic of my video lecture is bipolar junction transistor. Let's start. Here is the first slide. As you see in this first slide, we have a two figure. One is from one is on the left hand side and another is on right hand side. फर्स्ट आई विल एक्सप्लेन द फिगर ऑन द लेफ्ट हैंड साइड। जैसा कि आप देख पा रहे हैं ये एक सामने फिगर है और एज वी हैव डिस्कस इन ऑल प्रीवियस लेक्चर रिगार्डिंग पीएन जंक्शन डायोड, तो आप ये भी कह सकते हैं कि यहाँ पे पी और एन एक जंक्शन डायोड है और इधर एक एन और पी भी एक जंक्शन डायोड है। दो जंक्शन डायोड हमें दिख रहे हैं और हमारी फिगर में दो डिप्लीशन रीजन भी आप देख पा रहे हैं। एज यू सी इन दिस फिगर वी हैव टू डिप्लीशन रीजन, one is on the PN side and another is on the NP side. As you see in this figure, we have the three regions. One is the emitter, the second region is base region between two P-type semiconductor, and the last region is the collector region. As you see in this figure, again I repeat, we have the three regions: emitter, base, and collector. Basically, these three regions are three semiconductors. The emitter is the p-type semiconductor in this figure. The base is the n-type semiconductor in this figure, and the collector is the again p-type semiconductor. As we have discussed in my previous lecture in very explained way, the p-type semiconductor is the semiconductor which makes by adding some impurity from outside in the pure semiconductor to make them extrinsic semiconductor. If this is the acceptor impurity, then the semiconductor will behave like a p-type. Or if we dop the pure intrinsic semiconductor with donor impurity, then the pure semiconductor behaves like a n-type semiconductor. We need not to discuss much more about this in this lecture. Now we move further. As we know, the p-type semiconductor have the majority charge carrier holes which are moved here and there and becomes the main cause of conduction current. In n-type semiconductor, the things are different. Here is the movable charge carrier are electrons and majority charge carriers too, and they are responsible to conduct the electron by moving here and there. So in the bottom of the figure, we have some green arrow as you see, which shows the nomenclature regarding free electrons, negative ions, positive ions, and holes. As you see in this figure, we don't connect any battery from outside. It is a figure of p-type semiconductor, which uh, basically this is a figure containing a n-type semiconductor sandwich between two p-type semiconductor to become a transistor. In right hand side picture, as we see, we have a p-type semiconductor which is sandwiched between a two n-type semiconductor. In the right hand side picture, the things are some different. Here is the two n-type semiconductor. One thing again I want to clear here, this is a not like that we have taken a block of n-type and just put in between a p-type semiconductor, or we take a block of n-type and put between p-type and put take a semiconductor p-type put between two n-type blocks. No, it is not like that. It is for you to understand the figure properly. In practical form, we have a one crystal, single crystal of some semiconductor like germanium or silicon in pure form. First, we add impurity as our need. Uh, which which type of semiconductor we want to make? If we want to make a p-type semiconductor, we put the acceptor impurity. Then we put a donor impurity to make them n-type or p-type. It is not like that to make a blocks like that. So it is a single crystal. Now we come to the point. As you see, we have three regions here: emitter, base, and collector. When you see carefully the figure, we have shows here are two depletion layer in both figures. The depletion reserve form when two different semiconductor comes together, P and P type and N type. And the charge carriers move here and there and they neutralize their counterparts and some region near the junction free from mobile charge. So these the reason which we show by a single bracket in the bottom and its nomenclature is BE depletion region. BE means base emitter depletion region and again BC depletion means base collector depletion regions. B for base, E for emitter and C for collector. Second thing is that as its name indicate emitter. Emitter means it emits the charge carrier. Collector means its role is to collect the charge carrier. So we call it collector basically. And the base is a lightly doped thin region so that very small amount of charge carrier makes a recombination and this plays a very important role in amplification factor. We will discuss this in later slides. Let's move on next slide. Now this is again a picture inside transistor dynamics. As the name indicates the slides, we have some figure in right hand side. This is the figure which contains two batteries. Nomenclature is that VBE and VCB. VBE means base emitter voltage and VCB means collector to base voltage. We always think about before to start what type of biasing, what type of battery polarities connect to the N side and P side. It is very important for the transistor action. So let's make a small summary. In transistor, we have a three parts named as emitter, base and collector. And we have a two type of transistor, PNP transistor and NPN transistor. N stands for N type and P stands for positive or P-type semiconductor. And basically this is a P-type and N-type semiconductor which we have already used in case of PN junction diode. Let's move further. This is again a picture for your clarity. As you see in this picture, we have clearly shown that the two depletion region which is formed N and P junction and next is P and N junction. You clearly see the emitter, base, collector part of the junction transistor and we have the three terminal which we have seen outside the transistor which nomenclature E, capital B and capital C. Okay, let's move on. This is very important picture regarding PNP and NPN transistor, but this picture is slightly different. In later pictures, you have seen the block type figures of PNP transistor, and this is again a symbolic picture. It is a symbol of transistor in another form. You see the circle and some arrow comes inside in one picture, and in other picture, arrow comes outside. As you see the picture which is bottom in the left hand side, the arrow from emitter terminal comes outside and current from base region comes inside as shown by the arrow and current from the collector side is also comes towards the inside. So by this picture we may nominate it as the NPN transistor. In this figure we don't show any nomenclature regarding NPN transistor, but current is from emitter side not pointing in. If the current from emitter side is moved towards the outside, as you see the picture on the left hand side bottom of the slide, so current from the emitter terminal is pointing outside. So NPN not pointing in. This is a trick for your help to remains always in the mind. If the current of the emitter side move outside, then it is definitely an NPN transistor. And as you see the picture on the right hand side, upper side, the current, the arrow from the emitter side comes towards inside the circle. It means that this is a PNP transistor pointing in. P point and for in. So this is only a trick to remains very clearly in mind. PNP means the current from emitter side pointing towards inside, and NPN means current from emitter side move towards the outside. NPN not pointing in. In regarding, it's all regarding emitter current. So this is all just about the basically a symbol, and you must know about this. This slides regarding introduction to BJT. BJT means bipolar junction transistor. As its name indicate, BJT, bipolar, it means current is conducted by both type of charge carrier, electron as well as holes. So next move two points as the first points is what is a bipolar junction transistor and make a question mark. So we have to define in a very simple manner. A BJT is a three-terminal semiconductor device used to control the current flow. Three terminal means one is the emitter, another is the base, and the last one is the collector. It is called bipolar because it is used both type of electron and holes as a charge carrier. Function as an amplifier, oscillator or switch in the electronic circuit. These are the some application, but the main application of the transistor which is very important is it work as the amplifier to amplify the signal, basically to make the uh, amplitude bigger than what is it has the originally, basically to increase to enhance the condition which we have originally to make them large in simple language. Structure and terminals, basically as we have discussed, it has a three regions. Emitter region, the as its name indicate, it emits the charge carrier. Basically, base is a thin layer that control flow of charge carrier. How it control, we will discuss in the some next slides. The last one is the collector region. As its name indicate, it collect the charge carrier. Basically, BJT is a two type. We have discussed NPN and PNP. As its name indicate, NPN transistor, the current flow from collector to emitter. This is the direction of flow. In PNP transistor, current is flow from emitter to collector. And this is very important point. When you see the direction of current, by seeing the direction of the current, we have decided whether this is PNP or NPN. As I told in my early slides, that if the emitter current move towards the inside, it is PNP transistor. PNP pointing in. And if the emitter current flow outside the figure, it means NPN, not pointing in. It is a trick to remains the clarity regarding PNP and NPN transistor. Here is some applications like amplification of weak signals in audio and radio, switching in digital circuits, logic gates for computational tasks. And the last, there is some key characteristics, operates in three regions, active, saturation, and cutoff. We will discuss these three regions in very explained manner in next slides. Basically, in transistor, the current control by the small base current, and this is the key feature of the amplification. So the role of base is very important. These slides regarding the structure of BJT, as we know very well, emitter is a reason whose role to emit the charge carrier. So we have to make the emitter heavily doped, and this is the beauty of the semiconductor. If we make semiconductor heavily doped, the conductivity increase very largely and which helps to emit the charge carrier. If we make the semiconductor lightly doped, then it has the some less charge carrier regarding to the heavily doped semiconductor. The last one is the collector and moderately doped, not too much heavy and not too much low. So the doping is the moderately doped and large to collect the charge carrier. Next, the types of the BJTs, as you know, NPN transistor, two N-type regions separated by a thin P-type semiconductor, or P-type semiconductor is like a sandwich between two N-type semiconductor. More simple language. Current flow, basically in NPN transistor, basically electron are the majority charge carrier. So main flow of current is only because of electron. And voltage polarities, positive base emitter voltage, we will discuss in very explained manner in next PPTs. As you see the figure, the figure in the left hand side, you see first two figure are block figure and some two figures are circle figures. These basically are two symbolic figures of PNP and NPN transistors. As you see in bracket, we have shown the units of the current. The first figure is PNP transistor, and you see the current of emitter current in a milliampere. M stands for milli and A stands for ampere. And base current in the microampere. So as you see, the base current is very little in comparison to the emitter and collector current. And collector and base current are likely to be comparable. So this is again a slide of uh, some figures, and this figure of NPN and PNP transistor, and we have to discuss some important point here. As you see, NPN transistor, the emitter current arrow moves towards the outside, pointing towards the outside, and in PNP transistor, the emitter current's arrow pointing towards the inside. Just remember, PNP means pointing in emitter current. NPN means emitter current not pointing in. So not much more that. Here is some important points regarding the physical structure. As you see, emitter is a heavily doped and base we have already discussed. So now move further. Basically, how a BJT works. A BJT operates on the control of current flow through two junctions. Basically, it is a combination of two junctions, emitter base junction. We have the depletion region between these two junction, and another is the collector base region, and we have the another depletion region for this separate junction. So one is the emitter base junction, and we have the depletion region, and the another is the collector base junction. Basically, a small current at the base region control the current between emitter and collector. What does it point reflects? This point reflects that the role of the base region is very small, and by tuning the base region, we have controlling power on the collector current, and this plays a key role in the amplification action. We will discuss later. Charge carrier flow, as we know, in NPN transistor, emitter injects electron into the base. The thin base allows most electron to move into the collector. Why? As we know, the base is the lightly doped, and so its conductivity is low, and the most of the electron or holes which enter from the emitter, uh, just recombination is rate is very low, and almost all 95% to 98% move towards the collector region. So basic large number of recombination occurs in the collector region, and very small recombination, and this is the basic reason why the base current is in microampere. So this is again a very nice figure to understand you regarding collector, base, emitter. Just see and watch. Now again a working principle of transistor, and as you see this figure contains some new points. The points reflects some equation which is IE equal to IB plus IC. IE is the emitter current, IB is the base current, and IC is the collector current. As you know, BJT action basically depends upon the in which region our transistor works. What does it mean? It means that whether it is work in active region, whether it is work in saturation region, and whether it is work in a cutoff region. And active region, saturation region, and cutoff region of the transistor. Here, as you see, the active region basically responsible for the amplification action, and saturation region means it acts like a switch, means it is like a close, fully on, and cutoff region it is like open and fully uh, off, like that on and off switch. So this is another application of the transistor. If it work in a saturation and cutoff region, then we may use it as a switch. We have discussed, we have already discussed. And in active region, the main application of the transistor in this region is the application, which is in the active region. These is basically the three reasons. Now, basically, this curves regarding the IV characteristics of transistor, and you see this curves plots between the collector current and collector to emitter voltage VCE, and this curve have a different parts. As you see very carefully, the bottom of the curve by arrow shows that cutoff region. Cutoff means it is like a fully open, and saturation region it is fully like a on, and some active region in which current is a linearly increase with the voltage. So basically, we have the three region: active region, cutoff region, and saturation region. The flat part of the curve, or in other words, the line which is parallel to the x-axis, shows that the collector current remains constant with increase in the VCE. VCE means collector to emitter voltage. What does this mean? It means that when we increase the collector to emitter voltage, then the collector current is totally independent. But in starting, when we just start the curve, there is some portion when the curve is linearly vary with the collector to emitter voltage, and this is shows the shaded part on the left hand side, which is with the y-axis, and the another part of this curve is that when the whole charge carrier comes in the collector region, and they quickly recombine with their counterparts, and very soon the saturation is reached. And increase the base current, as we increase the base current or decrease the base current, this directly affects on the collector current. So from here we see that as we increase or decrease the base current, keeping VCE constant, the emitter current changes. So base current control the collector current. So this is the key factor of the amplification. Hope you understand. So basically cutoff region, both the emitter base junction and collector base junction are reverse bias. The transistor is off, and this is shown by the bottom curve of the shaded part, which is just touch some red lines near the x-axis. It is the just bottom line of the shaded part in the x-axis curve. So it is a off, so it is used in a switch condition. The second region is the active region. The active region means the uh, PNP transistor. that is left hand side, p type is connect with the positive terminal, and at n type is connect with the negative terminal. And again, the left hand side p is connect to the reverse bias, that is p is connect to the negative terminal, and n is connect to the positive terminal. Let's explain in some better ways. Here is some important points, but the biasing at last I will explain again. The transistor amplification, the input signals amplification used in the amplification circuits, saturation region, both in saturation region, both emitter base junction and collector base junction are forward bias. The transistor is fully on, allowing maximum current to flow. Now, some graphical representation here. Graph of IC versus VCE shows three reasons we have already discussed. Now, here is some figure which show more help regarding the biasing. As you see in this figure, we have to discuss the biasing. The biasing is very important. As you see in this figure, this is a NPN transistor, and we have connect the left hand side NP junction to the forward bias for transistor action. What does it mean? In forward biasing means the N type connect to the negative side and P type connect to the positive side. See carefully, in this region, we have to make our left hand side, that is NP junction, in forward biasing condition, which followed by the N side connect to the positive side of the battery and P side connect to the negative side of the battery. Now again, the right hand side of the transistor, that is PN junction, and this side has to be a reverse biasing. What does it means? For reverse biasing or in reverse biasing, the polarity is changed. The p-type semiconductor connect to the negative side of the battery, and the n-type semiconductor connect to the positive side of the battery, as it is clearly shown in the figure. Hope by this you may understand the biasing of the transistor. In PNP transistor, things are different, but one thing you have to keep in your mind, that the left hand side of whether it is PNP or NPN is always forward bias. The right hand side of the transistor, that is base collector, is always reverse biasing. The left hand side, that is emitter and base region, is always forward bias. So whether it is P type or N type, check it by the polarity. If it is N side, then for forward bias, it is connect to the reverse biasing. And if it is a reverse biasing, then N type is connect to the positive polarity. In forward biasing, N is connecting to the negative and P is connecting to the positive. Don't make any confusion. Make it clear by the figure. Whether it is NPN transistor or PNPN transistor, the emitter base region is always forward bias. The base collector region is always reverse bias for transistor action. Hope you understand my point. Now move to the next slide. So here is some mechanism regarding the injection of charge carrier. As you see, for a NPN transistor, electrons are injected from emitter to base region. For a PNP transistor, hole are injected from the uh, emitter to the base region. Diffusion across the base, as you know, base is a thin and lightly doped, so most of the charge carrier which enter from the emitter region in base and directly diffuse immediately to the towards the collector region. That's why the base current is very small in the microampere. So collection, that is the collector, here is show the reverse bias helps the charge carrier to attract towards the collector region. So here is again figure which show very clearly the movement of charge carrier and how they recombine in between the base and importance of the base. As you see in this figure, we have an equation which is given by IE equal to IC plus IB. What does it reflects? It reflects that the emitter current is equal to the sum of collector and base current. It means that emitter currents always greater than collector current, and it is much more in magnitude than the base current. Or we may say that the collector and emitter current are likely to be comparable. So let's move further. Here is some characteristics of the transistor, like three reasons: input and output characteristics. As you saw, the output characteristics of the transistor which we have discussed, and the input characteristics of the transistor which is between emitter and base region, so shows that the base current and emitter base voltage at a constant collector emitter voltage VCE. VCE means collector to emitter voltage, and VBE means base to emitter voltage. Our observations, as VB increases, IB rise exponentially due to the diode-like behavior. Or we may say that this curve is as simple as in the PN junction diode curve. Basically, it is a junction diode curve in which current likely to be increased uh, as we increase the voltage, then current is immediately increased after a certain value of the voltage, which is the new voltage. The output characteristics drawn between the collector current and the collector to emitter voltage VCE at constant base current. So here is some other points. Cutoff region means IC is 0, that is no output, and the active region, the IC increase linearly with IB. This is the active region for the starting part of the curve. And in this curve, we have the amplification action, that is saturation region, that is IC completely independent with the voltage, just constant with increase in the voltage. No effect to increase the voltage on the output curve. This is the saturation region which shown by the flat part of the curve. So here is some alpha and beta. You see I beta is a constant parameter or current gain as name indicated. Beta equal to IC divided by the IB, collector current divided by the base current. Here is the two figures regarding characteristics of a transistor. And the figure on the left hand side shows the input characteristics, base current and VBE, and the right hand side picture is the collector current, and on x-axis we have the collector to emitter voltage. It is the output curve. As you see in the output curve, as we increase the base current, that is 10 microampere, 20 microampere, 30 microampere, 40 microampere, uh, as we increase the base current, the IC increases. And for constant base current, the value of the collector current doesn't increase. As we see the first curve, where IB is the 10 microampere, after a certain value of VCE, then curve show a flat region. That is, it is the collector current almost independent of the VC. Again, as we increase the base current 20 microampere, then magnitude of the collector current increases. And again, after a certain value, it is a flat. As we increase the base current, then collector current increases. So this curve clearly shows that by collector current, we control the, sorry, by this curve, we have a message that by small base current, we have controlled the large collector current. And this is the key feature of the amplification. The left hand side curve is a input characteristics curve of a transistor, and it is just like a diode PN junction diode curve. Simply a base current, and on x-axis we have a base emitter voltage. As we see, we increase the collector to emitter voltage, that curve is slightly increased, and it is just like a junction diode curve. After a knee voltage, the current varies linearly with the base to emitter voltage. It is as simple as a diode junction curve. Now this is a basically working of a PNP and NPN transistor. As we have the uh, we know that the terminal which is common to both, known as the common base. The picture which you have seen in the slide now is a common base NPN transistor. Why it is common base? The base terminal is common to both emitter and collector. That's why we called it common base. The terminal in the transistor which is common to both terminal, that reflects in the name. If it is emitter terminal which is common to both, then it's a common emitter. The terminal which is common to both, if it is collector. And now in this figure we have just we see that it is the base which is both side common, emitter and base, so we called it common base. Now move further. So this is again a picture with containing some equation, um, as you have already seen in previous picture. Here you again see the biasing of PNP transistor. The left side of emitter base is forward bias by collecting P side on the positive and N side on the negative, and the right hand side on the reverse bias. That is the important points. Just read, and we have discussed all these points already, and we have already discussed these points. This is nothing much more here to discuss. We have already discussed. Now we come to the question and answer. So this is the question answer session. Here is some important question for you. What is the primary function of a bipolar junction transistor? As you see, it is a uh, amplifying action. And next one is the in a PNP transistor, what is the direction of the conventional current flow? Basically, from emitter to collector is the right answer. As you see, all the options here in the question, just read one by one and first check and then give the answer. Here I directly give the answer for you, simplicity. The next one is the what is the phase relationship between input and output in a common emitter amplifier? It is out of phase by 180 degree. And the last one is the in which region does a transistor operate as a switch is in the on? As you see, in a saturation region we have a on state, in cutoff region we have a off state, and in active region we have a amplifying state. These are the three parts. Before to close this lecture, I just want to explain transistor output characteristics curve have three regions: active, saturation, and cutoff. So cutoff region is basically a no output, IC 0. Saturation region is a on state, and active region is a amplifying action. Amplifying action. Hope you enjoyed this lecture. I just try to cover all the topics. Hope maximum topic has been covered. Wish you very best of luck for your exam, and thank you very much. Good day.